Alrighty, welcome back to another video, and in this one, I just wanted to respond to a couple questions that I got in the last video. The first one was about mining in the puzzle, and for that I want to mention that I'm actually going to be teaching this topic in more detail in a separate blockchain series. So for the sake of preventing duplicate content, I'm going to hold off on that for now. Really great question though. And the other request that I got was to explain a little bit more about proof of stake. So that's what we're going to be going over in this video. So let's go ahead and hop right into it. So as we mentioned in the last video, Ethereum is moving from a proof of work system to a proof of stake system, which is really just an alternative consensus mechanism. And what it boils down to, the main change is that instead of letting nodes with the most computing power generate blocks through work, or in other words, energy use, the proof of stake system is going to allow the nodes who stake their ether. And by staking ether, I basically mean just depositing it into the network as collateral or locking it up. So the nodes who stake ether are going to be the ones able to generate blocks. And this change comes with a couple of key benefits. The first one, pretty obvious, but of course worth mentioning, and that is with this new system, there is no longer the requirement for, these huge investments in hardware or energy costs. So that's of course good for the environment and, a lot of different reasons not to use excess energy. Now, the other benefit is that this change actually allows for a few technological or architectural improvements, and we're going to be taking a closer look at those throughout the video. Now, the first component of this architecture that I want to take a look at is something called the shard chains, S-H-A-R-D. And before we can even get to them, we do need a very basic understanding of what sharding is in general. So sharding, technically, it's the process of splitting a database horizontally to distribute the load. So what does that mean? So imagine that you have one computer and it only has 3 gigabytes worth of memory in total. The entire hard drive, it only has 3 gigabytes. So you install a database on it and it's growing. Okay, 1 gigabyte, 2 gigabyte, 3 gigabyte. Now you're maxed out. So what do? Well, you can keep buying a bigger hard drive and then a bigger one and then a bigger one. But eventually you're going to come to a point where, well, quite frankly, they don't sell hard drives big enough for what you need. So another option is taking that same data and splitting it out across multiple machines. So instead of one computer where you max out at 3 gigabytes, you can set up 3 different computers, and then you can take this gigabyte, put it on this one, this gigabyte, put it on this one, this gigabyte, and put it on this one. So your total capacity now, instead of 3 gigabytes, is 9, and you still have 6 remaining gigabytes of free space before you need to scale again. So again, sharding is just taking a big chunk of data and splitting it up to help distribute the load. Now with the proof of stake update, what Ethereum is planning on doing is taking this key concept of sharding and porting it over to the blockchain ecosystem through the creation of these right here, which are called shard chains. And I'm sure you can guess what the point of these is. Basically to take one big monolithic chain, one big main chain, and splitting up the data into smaller shards, or in this case, shard chains. So for Ethereum, the plan is actually to have 64 of these shard chains. I just drew 3 on here because, well, I didn't want 64 chains clogging up my UI, but you get the idea. So with these shard chains, validators only need to store, or in other words, run the data for the shard that they're validating and not the entire network. So this reduces the hardware requirements for each node by allowing more people to participate, therefore improving security through greater decentralization. So once a node is in the validator pool by staking enough ETH, then they can be assigned to a certain shard. So again, the validator pool is just a list of eligible nodes, and it pretty much just means whenever you staked enough ETH, which is 32, that you're eligible to become a validator. Now these shard chains, they're often called the data layer, DATA, and that's because, I'm sure you can guess, but it's where the majority of the data of the network is going to be stored. Now there's also another layer or chain in the system, and that's called the beacon chain. So this is often called the coordination layer. So again, the coordination layer and the data layer. So let's go ahead and talk about this coordination layer. So because there are 64 shard chains in this new system, coordination between them is necessary, and that coordination is going to be done by the beacon chain. So what the beacon chain is going to do is it actually does quite a few things, but one of the important things is that it's going to receive state information from these shards, and it's going to make it available to other shards. So it essentially allows the entire network to stay in sync. Now, another thing that I want to mention is that it's really the transactions themselves that are split up across these shards and not the actual network state. Now, by network state, I mean the current state of the network, not so much the historical state. Now, the reason is that the transactions are basically the long-term storage. And after processing them, each validator, it doesn't really need to keep a record of them anymore in terms of the validation process. They really only need to know the current state of the network in order to properly validate incoming transactions. So now let's see how some of these pieces fit together. So starting from the very beginning, users are going to need to stake 32 ETH to become a validator in the network. Now, validators, they really just do the same thing before, just without the puzzle, mainly responsible for validating transactions and creating blocks from those transactions. Now, in this system, certain validators are going to be algorithmically chosen by the beacon chain to propose new blocks. And these validators are called the proposers. Now, the other validators are responsible for checking and confirming the blocks proposed by the proposer, and these other validators are called the attesters. Now, these validators can lose a portion of their stake for things like going offline or failing to validate, and they can actually lose their entire stake for deliberate collusion. In other words, if they are intentionally trying to be malicious somehow. So a validator's stake is also used as a way to incentivize good behavior. So what happens is whenever you submit a transaction to the network, a proposer is going to be responsible for adding your transaction to something called a shard block. Just copy this and get this new shard block going right here. All right. So for any of the validators that aren't chosen to propose a new shard block, these are called the attesters. And they're going to have to attest to another validator's proposal. In this case, this one is the proposer, and pretty much confirm that everything looks good as it should. Now, attesting, if that term kind of confuses you or you're not familiar with it, you can think of attesting as pretty much just saying, hey, this block looks good to me. Another cool fact, well, I don't know, cool, interesting, I guess, is that it's actually the attestation, as it's called, I believe that's how you pronounce it, that's recorded on the beacon chain and not the transaction itself. So attestations, or in other words, these sayings of, yep, this block looks good to me, that's actually the main source of load on the beacon chain. So now let's get into committees, slots, and epics. So even though I drew these groups kind of simple with only 4 nodes in them, in reality, there are at least 128 validators. Again, that's 128 that are required to attest to each block. And that group of validators is technically known as the committee. Now, each committee has a time frame in which to propose and validate a shard block. And this time frame is known as a slot. So a slot is really just a chance for a block to be added to both the beacon chain and the shards. Now, just as some additional info, each one of these slots is actually 12 seconds long, and an epic is just 32 slots, and it ends up being right around like 6.5 minutes. But again, each slot 12 seconds long, and there are 32 slots in something called an epic. Now, only one valid block is created per slot. Now, after each one of these epics, what's going to happen is that these committees are going to be thrown back into that pool, randomized, mixed up, and new committees created. And this really just helps the shards keep safe from bad actors, or whenever you have nodes in there too long, they may start colluding. So really just help to keep the network safe through randomization. Now, just to mention the reward process real quick is that these validators, they actually get rewarded for proposing and attesting to blocks. And like we said before, if any of these validators attest to a malicious block or a block that they shouldn't, maybe it's invalid for whatever reason, that they will actually lose their entire stake. Now, the last thing I want to discuss is a topic called crosslinks, and that is once a new shard block, actually let me duplicate this. So duplicating this, but it's actually referencing the same block, and you'll see why in just a second. but essentially what I wanted to say is that once a shard block has enough attestations, then what's going to happen is something called a crosslink is going to be formed. And this essentially just confirms the inclusion of the block in the beacon chain. Now these crosslinks right here, again, are how the beacon chain are going to follow the head of the shard chain. And by knowing the head of the chain, you can essentially identify the updated state for the entire chain. And this is what is going to allow all of these shards to stay in sync, something like this. So again, I know that there's a lot with this proof of stake system. The good news is if you are primarily a developer writing Solidity contracts, wanting to create dApps, you really don't need to know too much about this. However, this was just a response to some of the questions I was getting in the last video. So there you go. There's your quick overview on proof of stake. Hope you enjoyed it, and I will see you in the next video.